So hello. We're about to get into some quadratic modeling problems, meaning fitting a parabola to a real-world situation, and it's pretty applicable. You know, if I just take this marker and I just throw it across the room, barring wind resistance and air resistance, of which there is a little bit, that marker is going to follow a parabolic shape. And if we think about the function of the height of the marker off the ground as it relates to the amount of time that has passed since I released the marker, that function is going to be quadratic. Okay, because the shape is a parabola, is a perfect parabola, if there's no wind resistance, the equation is going to be quadratic. Let me get this marker for a minute. Okay, so with the problem that I have on the e-board is this guy. I've scribbled on it a little bit, but it looks like this with the graph. Okay, I've done my best to redraw this up on the board, and I'm going to go through a bunch of these questions because I want you guys to have a little bit of a background with an application of a quadratic function before just doing problems in class. All right. So the key things to look out for, of course, one characteristic of a quadratic is that it has what's called a vertex, which is either a maximum point or a minimum point on the graph. And in this case, we have a maximum point. Think about what that point represents. Well, in this case, because we're talking about the time, the elapsed time, I should say, so the time that has passed since a projectile was fired, and the y value is the height of the object in hundreds of meters. Or actually, I should say it's the height. To find the height, you would multiply the y value by 100. Well, the maximum point is going to tell us two things. The vertex is going to tell us two things. The x value will tell us the amount of time that has elapsed where that projectile has reached a maximum point. And the y value is going to tell us what that height is, what that maximum height is. So in problem 3, you see this. Problem 1 asks you for the coordinates of the x-intercepts. I've written them here. The number 2 asks us for the line of symmetry. Well, that's just halfway between the x-intercepts, 6.25. So number 3 is the real key here. Okay, the vertex. If you're asked about the maximum height, that is talking about the vertex here. So we've got to figure out the y value. We've got to figure out the y value, the height when x is 6.25, right? To find the vertex, you first want to know the line of symmetry, and then you plug in that x value into the equation, right? You can check a table also, but with an x value of 6.25, it's not going to show up on your table. I'll show you in a second how to find that, though, if you give me a minute. All right, so to find the height, I've just plugged in 6.25 into the equation, which is on this sheet. The function was, it's right here, negative 0.08x squared plus x. I plugged in 6.25 for x and squared it here first, then multiplied, of course, because of PEMDAS. Add these up, you get 3.125. So f of 6 1/4 is 3.125. That means with respect to this problem, we times it by 100, move the decimal over twice. 312.5 meters is the height, is the maximum height the projectile reaches. All right? So that's that. Because again, this point on the graph is 3.125. This means that the maximum height, if we were asked a problem in words, is 312.5 meters. All right? Now, very quickly, let me show you something on your calculator. All right, you are used to seeing this table. So you see right here, you can kind of tell that somewhere here is the vertex because the value of y is increasing, increasing, increasing. It reaches some top point, some high point, somewhere around there, and then it goes down again, right? Between 6 and 7, it reaches a high point. So to find the exact point, again, we can use the x-intercepts and say, okay, halfway between that is 6.25. That's where we reach a maximum. Now, how do you find that on the table? Let me show you. You hit second window to go to the table set, which I've shown you once before. But then you go down here to where it says independent and where it says auto. Slide over to ask. Okay? And then go back to the table. And now it looks like it's blank. It is blank, all right? But now you can enter whatever you want for x, and it'll give you a corresponding y value. So like 6.25, hit enter, and there you go, 3.125. Okay? It's a very nice feature of the table. All right? So you can program it to ask and then plug in whatever you want for x instead of just seeing all the points. All right? So that's one way to show instead of having to plug in and do the tedious math. All right. Problem 4 says, determine the exact height of the projectile after 8 seconds. Okay. Well, we can do that in one of 3 ways. To determine the height after 8 seconds, we're finding the value of y when x is 8. So say this is 6, so 8 is probably around here. So we're finding the y value there. We know this point is 8 comma something. That's what we're finding, right? F of 8. So we can use the graph to see sort of approximately where that is, right? Because the graph, you kind of look across, you might see around where it is, but not exactly. So in this case, I'm asking you for a specific and exact measurement. So the graph is least reliable, okay, in that case, because you don't have the exact point where x is 8, all right? So it's safer to use the equation, find f of 8. All right, this is problem 4, by the way, right? So 4 asks you for f of 8. It's going to be safest to use the equation, okay? But the equation is kind of tedious. So why not just go back to the table? If we're here, we can just type in 8, and we get 2.88. Now, if you had the table up the way you had it, because 8's a whole number, you could just scroll up and down and see that. You wouldn't have to type it into this special feature, all right? 2.88 is the approximate value. Well, with respect to, it's not 2.88 meters, right? This again means it's 288 meters, approximately, all right? And then problem 5 says, which representation? I already spoke about problem 5, right? I think the using the table or using the equation is the way to move. Either one is fine. Okay, they're going to give you the exact values. The graph will just show you approximately where that happens. And because my scale is weird, this looks like it's above 3. So this is done by hand, but 288 meters. Problem 6, look back at the height you found, so 2.88 business. The projectile will reach this height once more. That's right, it will reach the same height of 2.88 once more on this side of the line of symmetry, right? Over there, it will also have the same height as it does at 8 seconds. So I'm asking you, well, what amount of time has elapsed to give us another height of 288 meters? So you've got to find the x value of this point. Okay? Well, if you think about it, because of symmetry, well, 8 is how far from 6.25? Well, it's 1.75, right? 8 is 1.75 more than 6.25. So if we go 1.75 back here, so 6.25 minus 1.75, we are at, well, 6.25 minus 2 is 4.25, so it's 4.5. Right? So 4.5 seconds would give us the same y value, 288 meters. Now, we could check that using the table, right? One thing I guess we could do is just type in 4.5 and see, yeah, you get the same value, okay? You also could go back to the table set, and instead of making the independent variable the ask, go down to the dependent variable and change that to ask. Now go back to the table. This should work. Maybe it doesn't work. Plus? No, I'm sorry. Something's messed up in my calculator. So we can't really do that yet, all right? But I think it's easiest just to see, sorry about it, ignore the last 30 seconds. 8 is 1.75. Again, this is 6.25, right? The line of symmetry. 8 is, that distance is 1.75. So go back 1.75 and you're at 4.5, okay? That's how to really answer that question. And you can just check your work on the calculator, all right? Next problem. Determine the exact height after 2.5 seconds, okay? And state another time where that happens. So after 2.5 seconds, we've got to find the exact height. So that's problem 7, right? So problem 6 was 4.5 seconds. That was the answer. Problem 7 is we're trying to find f of 2.5. F of 2.5. Find the height after 2.5 seconds, right? Determine the height after 2.5 seconds. Okay? So just a little bit of an extension here. Or no, it's not. It's just kind of a review. It's the same kind of problem as 4, I guess. So again, if we have the table all set up, nice and neat, table set, again, you want to have this showing, and go to ask, and then go back here and just type in 2.5. And you get 2. And again, that means 200, right? 200 meters. So the height after 2.5 seconds is 200 meters, all right? Now, because it's a nice whole number, on the graph, we probably could see this. Ignore the scribbling here. With 2.5 seconds, see this dot right there? That's pretty clear that it's at a cross section, all right? So it is pretty clear on the graph that is the value of where x is 2.5. We get a y value of exactly 2. Now, where else that happens, again, is on this side over here, right? Where you have x is 10, where x is 10, you also have a height of 200 meters, okay? So on the graph, you can see that pretty clearly, all right? And that's because 2.5 and the number 10 are the same distance from 6.25. Again, just to check, we could type in 10, and yes, you get 2 once again. All right, so after 10 seconds, so this is about 10, the height is 200, and then over here, after 2.5, the height is also 200 meters. All right, so I'm just reinforcing the idea of symmetry. All right, I know that was a little bit redundant to see that twice, but you see there are two values where the height is 200 meters, right? The projectile is going up, hitting 200 meters, hitting a maximum, and coming down and hitting 200 meters. Same thing for the 288 meters. That happens twice as well. All right? We're at 11 minutes. Okay, this is getting a little long. Okay, let's cut it off at that. We'll talk about the rest in class. Okay? Have a good night.